order of the sort, like what we said it yesterday, the cap number is same in all the case. So today from model to simplification, one question I am going to do and one question you will be doing by yourself. So let's see a question in PIP, please. Question in PIP, and then I am going to copy the first question here. (81) x to the power 8 y to the power minus 12 z to the power 4 divided by cube root 27 x cube y to the power 6 z to the power minus 9. And dear student, this first question I am going to do, and the second question, similar question, is to try by yourself. So please look at the board, please. I am going to do the first question here. I have already copied the question. Now, you know what is the difference between the questions that we solved yesterday and I am going to solve today. This order of the sort, this order of the sort is 4 here, order of the sort is 3 here. You can see this one and this one, they are not same. Yesterday you practiced some questions in homework and I myself did, I think, 2 questions here, and then both the questions that I did have order of the sort same. Either they were 4-4 or they were 3-3, actually same. But today I have taken similar example. This is also same like what we did yesterday, but the difference, one and only difference is that order of the sort is 4 here, order of the sort is 3 here. Now in this case, so let me tell you at first, for this question we can also write it as divided by, means divided by so this question can be done by 2 different methods. Method number 1, converting both the sorts in like sorts. To convert into the like sorts, we need to take LCM of 4 and 3. Like LCM of 4 and 3 comes 12. So we need to multiply this order by 3, this order by 4. That way also we can do, but that is a little longer. So let me tell you how to solve this question using laws of indices. At first, let's factorize the number. 81 means 3 to the power 4. Then x to the power 8 is there, y to the power minus 12 is there, z to the power 4 is here. Similarly, in the denominator, cube root 27 is 3 cube into x to the power 3, y to the power 6, z to the power minus 9. So what we had done yesterday, we manage one big sort and we we include both these all radicand into the same sort because there were same order of the sort. For this we cannot write 4th root and something like this. This will be wrong. Neither we can write cube root this upon this. Both will be wrong. We cannot go that way. So how should we do? Here, turn by turn, we need to remove the that radical sign, that upper one at first. To remove this radical sign, we need to divide this power 4. 3 to the power 4 is there. This 4 must be divided by order of the sort. Then radical sign will be removed. Similarly, here is x to the power 8. X to the power 8 should be divided by this 4, order of the sort. Y to the power minus 12 should be divided by order of the sort. Z to the power 4 is here, should be divided by order of the sort. Upon 3 cube is here, x cube is there, y to the power 6 is there, it should be divided by order of the sort 3. Z to the power minus 9 is there, should be divided by order of the sort 3. So this way we can remove the sign, radical sign. So now you need to remember, if the operation is division and multiplication, I have told you many times, when operation is multiplication or division, we can remove the radical sign by dividing this power of the number by order of the sort. And the same thing I have done here. Now look, this 2 we can cut, this 2 we can cut, 3 we can cut here, 3 cuts 6 2 times, 3 cuts 9 3 times, it will be minus 3, 4 cuts 4 1 times, 4 cuts 12, it divides, in fact 4 3s are 12, 4 2s are 8. Then this will be 3 to the power 1, no need to write 1, 3 simply you can write here, x to the power 2, y to the power minus 3 and z. 3x y square z to the power minus 3, you can see. 3 we can cut. Now let's see, dear student, here base is x, base is x. So we can operate their power like, let's write x square is there in the numerator. Here x is here, it means x to the power 1 is there. 1 goes up and it becomes minus 1. Y to the power minus 3 is here, y square is here. So let me take it to the denominator. Into z is here, z to the power 1 is there, here is z to the power minus 3. This minus 3, when it goes up, we should add the power. And the rule that we have used here, we have already discussed, don't be confused. We have been discussing about this rule since last 2 days. Now this is y square, y to the power minus 3 is here, it goes down and it becomes plus 3. So finally what is the answer? X z to the power 4 over y to the power 5. I hope you have understood this question. You can see what I did. At first I removed the sign of radical by dividing internal power of the terms by order of the sort, and then after simplification we got the result as x z to the power 4 y to the power 5. So this is what we did yesterday, actually, this model. So dear student, again let me show you the slide just for your task, please. Slide please. So this similar question you need to try by yourself. Second one is your homework. Okay, so this is one of the important model that we discussed, and now we are going to next model that we are going to do today. You can see model 3 in the screen. So please copy out this question. Okay. So a to the power x over a to the power y whole to the power x square plus xy plus y square, a to the power y over a to the power z whole to the power y square plus yz plus z square, a to the power z over a to the power x whole to the power z square plus zx plus x square. Now let's see in the board, please. This is the model 3. I hope, my dear student, you have also copied the question in your copy. So this is again one of the important type of question that you have been learning. In fact, I think that this type of question was there in 7 as well, in 8 as well, in 9 also you have been learning. and even in standard 10 and some faculty of upper level also you need to know the concept of such question. This is the third model, and here we are going to simplify it. So when you learned factorization in algebra, that you were told that factorization is the backbone of the mathematics. You need that formula factorization everywhere. So here also you need to remember that what you have already learnt in factorization, and that you are familiar with Bodmas rule, that at first we used to do the work inside the small bracket, yes, and then we go out of the bracket. That rule you have followed in to simplify many questions. So same thing I am going to apply here. You can see this is the bracket. So inside the bracket at first we need to do. Before that, I am going to remind you one law of indices. Base is same. This is A, this is A. Both base are same. We can write single base, and m is there. Now m goes up and it becomes minus m. This rule we have already discussed. So let's follow this law at first. So it will be a to the power, x is there in the numerator, y goes up, it becomes minus y to the power, what is this? X square plus xy plus y square. Follow the same process, dear student. This one is a to the power y. This z, when a to the power z goes up, the power becomes negative, a to the power minus z, and finally it will be y minus z. And to the power you can see y square plus yz plus z square. Similarly, for the last term, a to the power z is in the numerator, a to the power x, it goes up, it becomes minus x to the power z square plus zx plus x square. So in this way, dear student, this is the major step that you should remember, and obviously you know it because this is the laws of indices. Then you have already learned. I have just used this law, first step. Next law, let me remind you that we have already done. This is why I am just going to remind you only. Raise power to a power law. Raising a power to a power law. Like here a to the power m, and it is again raised by another power n. And here as well you need to use a to the power, this m, and bracket means multiplication, m into n. I hope you have understood this law very well. So using this law we are going to simplify this, like here x minus y, x square plus xy plus y square. Using this law exactly in this step, what it will be, dear student, at the place of m you can see x minus y has come, and at the place of n you can see x square plus xy plus y square has come. Okay. Then similarly here a to the power y minus z is here. It should be multiplied with y square plus yz plus z square. And next one, a to the power z minus x is inside, should be multiplied to z square plus zx plus x square. So, dear student, this first step, this law, second step, this law. We are learning laws of indices. So we have been using the laws to simplify such questions. This is so easy question, every one of you can do, I guess. Now look, there is a minus b, a square plus ab plus b square type expressions you can see. This is in the form of a minus b, a square plus ab plus b square. So we can write it in cube form like x cube minus y cube. Similarly, this one is, again here you can see, like a minus b, a square plus ab plus b square. So it is y cube minus z cube. And again here you can see a to the power z minus x, z square plus zx plus x square. It means z cube minus x cube. So here we have used the formula of a cube minus b cube. So if we talk about the third step, dear student, in third step, let me inform you here, remind you, a cube minus b cube is equal to a minus b, a square plus ab plus b square. We have already discussed. So like to be more confident, you can once multiply these two by actual multiplication. If you multiply a minus b and a square plus ab plus b square, obviously you will get a cube minus b cube. And a cube minus, from a cube minus b cube as well, we can prove a minus b, a square plus ab plus b square. We have already shown in our previous classes. Okay. Now, this formula is, look, first step law, second step law, third step formula. And again, next law, dear student, what is the base? A is the base. What is the base? Again, A is the base. What is the base here? Again, A is the base here. So, as every term is having base A and the sign of operation between them is multiplication, again, next law of indices is used. So, that will be, let me again remind you the laws of indices. If a to the power m is multiplied to a to the power n, the result becomes a to the power should be added, it will be m plus n. Now using this rule, at last we get the base is a, x cube minus y cube is the power of a of first term, plus this power is going to be added, y cube minus z cube, plus this last power is z cube minus x cube. Okay. Now we are almost at the end of this simplification. This is one of the most easy questions in student. Now you can rearrange the term like x together, z together, y together, or now you can cut in this way. Cutting the terms means we are subtracting. Like 2 minus 2 is 0. 4 minus 4 is 0. 2 cube minus 2 cube means 8 minus 8. It is also 0. Similarly, x cube, this is x cube minus this is x cube. X cube minus x cube, result is 0. Therefore, we can cut. Plus y cube minus y cube, result is 0. Plus z cube minus z cube, result is 0. So finally, a to the power, what came here? A to the power 0. And again, laws of indices. Something to the power gives the result 1. Okay. So a to the power 0, b to the power 0, 5 to the power 0, 5 crore to the power 0, something to the power 0, it gives the result always 1. This is also the laws of indices we have already discussed. So finally this is equal to 1. Answer. Did you copy? Did you copy, dear student, this question? I hope you have copied. So now again I am going to show you the slides now. I hope you have copied this. Now look at the slide about some more question. This is what we have just done. I hope this model 3 you have already done. So you can see in PIP one question is there, and now this question that you will try today. Next question I will show you. Okay, so dear student, you can see in full slide I want to show you once. Okay, you can see these questions. Today time is almost I am at the end of the time, so I cannot do this question further. So dear student, let's see in PIP, this is your homework, practice at home. Please, this is the homework you need to practice at home and submit in www.classroom.google.com. The code is 3AAZUU7. Their PDF file, if you send, I can check your homework. So thank you so much for being with us. My time is over for today. Tomorrow again we will come with the same lesson but different questions. Till then, goodbye, namaste, stay safe.